Alright, here are the answers for the similar triangles and slope assignment. The first question, what is the rise of triangle ACE? So here's ACE. Remember, we're finding the rise to help us find that rate of change. The rise here, it starts at 20 and it goes up to 80. You can't just count the boxes. 20 to 80 is 60. If you had $80 and I had $20, the difference is 60. So it rose 60 miles. The run, remember, is how far we went over. So it started at 1 and it went all the way to 4. So from 1 to 4 is 3 hours. So the slope, or the rate of change, is the rise over the run, and then you need to reduce it. 60 over 3 is the same thing as 20, and don't forget the labels. The labels are, the 60 meant miles, the 3 meant hours, so it's 60 miles per hour. All right, let's look at the smaller triangle right here, BCD. So the rise, it went from 20 to 60. 20 to 60 is 40 miles. The run only went from 1 to 3, so that was only 2 hours. So the slope, remember, is the rise over the run. So that is 40 to 20, which is still 20, sorry, it is not 20, it is 2. 40 to 2, which is 20 miles per hour. So predict the speed from 8 seconds to 10 seconds. Well, 8 seconds to 10 seconds, it doesn't matter where we are on this line, he's going at a constant rate of speed. So even way up here at 8 seconds and 10 seconds, he's still going to be going 20 miles per hour. So it wasn't asking how far he went during those 2 seconds. It was asking for his speed or his rate. All right, let's look at question 2. Question 2, I think, is the one that gave people the most difficult time because it's difficult to see where the graph or the line crosses the coordinate plane exactly. So what you're trying to do is find points where it's exact. So right here, it's a little bit above. Here, it's a little bit below. So at 150 is the first time that it crosses exactly. So I'm going to put a point there. And then it crosses exactly up here. And I'm just going to put another one, even though it only says to use 2. Choose 2 points. So, and it actually crossed at 0, 0, 2. So I'm going to go between these 2 points. So I'm going to draw my dotted line, and then I'm going to use one of the points. Again, I'll just start with this one right down below and go up again and over. So there are my 2 triangles. Now describe the relationship between the 2 triangles formed by the lines. Well, I could say they're overlapping. I could say that all 3 angles are congruent. I could say they're similar triangles. All of these would be good answers. Similar triangles. And then it talks about the slope. Well, the slope between the 2 triangles, we had to go from 150 up to 300. Let me show you where I'm talking. 150 to 300. So the rise was 150, and the run was 2 because it went from 2 to 4. So that slope is 75 degrees per minute. And I got the degrees per minute because remember the rise was in temperature, the run was in minutes. And then I could look at my other one. We went from 150 all the way up to 450, which was 300 for 4, which also is 75 degrees per minute. So I could say the slopes are the same. All right, next question, we have to draw a line that starts at 0, 0. And you all know that it's there at 0, 0 in the corner. And it says that it has a slope of 2 and a rise. So 2/3 is the slope, which means it has a rise of 2 and a run of 3. So I'm going to go, and I'll point to it first, up 2 over 3. Up 2 over 3. And every time I stop, I'm going to put a new point. So I'm going to go up 2 over 3, put a point. Up 2 over 3 and put a point. And continue this. Where I saw many of you make a mistake is not connecting the points when you're done. Remember, you're drawing a line. So we would connect it like that. And then it says to label. So I'm going to just say this is my A, B, C, D, E, F. 1, 2, 3, 4, 5, 6. Okay, and I could have even made another point right there. All right. So then it says connect the vertices 0, 0, 0, 4, and 6, 4. So many of you had a difficult time with that too. Here's 0, 0. 0, 4, I saw many of you going over first, but 0 means how far you're going over and then up. So 0, 4 is right here, and 6, 4, so we have to go over 2, 4, 6 and up 4, so it's right there. So this is the triangle that we're talking about. So the geometric shape that it's talking about is a a right triangle. Then we're going to connect the vertices 3, 2. So here is 3, 2 right there because we have to go over first and then up and down. Make sure you're correcting, not just watching me correct your paper. And then over 3, up 8. So it helps me to number my axes. So 2, 4, 6, 8. 8. And so over 3 up to 8, and then 12, so we have 6, 8, 10, 12, and 8, which would be right there. So here is another right triangle. And how do the two figures compare to one another? Well, they're both right triangles. They have corresponding, we talked about that, corresponding angles that are the same. They're in proportion, so they are similar triangles that have the same ratio rise to run. And we know that because right here it goes up 4 over 6. So I'll write that over here. 4 over 6 is the same thing as 2/3, which makes sense. We were told in the beginning that it had a slope of 2/3. And then this one here went up 2, 4, 6. So 6, and then it went over, so the run was from 3 to 12 was 9, and that's 2/3. So they have the same ratio of 2/3 for their slope. For the equation, we could have actually written it without all of this work because we were told the slope in the beginning, or that rate of change. Remember, the rate of change is the coefficient of x, so 2/3 x. So we're taking that rate, that common rate, and we're writing it as a coefficient. So we got y by taking 2/3 of x. Now this one right here is a level 4 question, and basically what I'm asking is, can you find some points that are off the grid? So I'm going to open it back up and make the graph a little bigger to show you how to do that. So there's a few different ways to do this. One way is taking that equation that we just wrote, y equals 2/3 x, and plugging a number in for x that we don't have on the graph yet. So we have 12. This would be 14, 16, 18, 20. Let's do 24. If we put 24 in for y equals 2/3, if we put 24 in for x, we could just do this multiplication. 3 goes into 24 8 times. 8 times 2, y would be 16. So that would be a point way over here somewhere, like probably right here, that we could go over if the graph continued. The other way you could do this is using your similar triangles. So from this point you could go up, from this point, which looks like it's at 18, we could go up 2 and over 3 to figure out what that would be. So the x would be 21 because this is up 2, so 10, 12. So this next up 2 would be 14, so up to 14 and over to 21. So that point right there would be 21, 14. So there are a couple different ways to find extra points.